Eastern Front, July 1943. The dusty plains near Prokhorovka offered little cover, just vast, undulating fields where the summer heat shimmered, distorting the distant silhouettes of Soviet armor. It was here, in the crucible of Operation Citadel, that the German tank crews first truly encountered the American M4 Sherman, not as an abstract threat, but as a tangible, if initially unimpressive, opponent. The stakes were immense: control of the Kursk salient, a strategic linchpin that could turn the tide of the entire Eastern Front, hinged on the outcome of these armored clashes. Oberlieutenant Klaus Richter, commander of a Panzer IV Aust FH within the 2nd SS Panzer Division Das Reich, squinted through his periscopic sight, observing the advancing enemy column. His unit's intelligence briefings had mentioned the arrival of American Lend-Lease tanks, but the initial visual assessment of the M4 Sherman lumbering across the steppes evoked a dismissive chuckle from his gunner. Its high profile and somewhat boxy turret seemed a stark contrast to the sleek, low-slung menace of their own panzers. Richter's Panzer IV, a formidable machine weighing 25 tons, mounted the KWK-40L-48 7.5 centimeter gun, a weapon capable of penetrating 90 millimeters of armor at 500 meters with its PZ-GAR-39 rounds. This was a gun designed to tear through the T-34's sloped glacis, and the Sherman's relatively flat, 51 millimeter thick frontal plate, even with its 56-degree angle, appeared an easier target. The perceived inadequacy of the Sherman was not just a morale booster. It was a tactical calculation, a belief that their superior optics and firepower would quickly dismantle these foreign intruders. The Sherman's 75mm M3 main gun, while effective against earlier German tanks, was considered underpowered against the up-armored Panzer IVs and Tigers now prevalent on the Eastern Front. A damage report from a captured M4A2 Sherman indicated that its M61 shot, a high-explosive anti-tank round, could only reliably penetrate 76 millimeters of vertical armor at 500 meters. This quantitative disparity fostered a confidence bordering on arrogance among the German crews, who had become accustomed to their technical superiority over most Allied tanks. Production logs from the American automotive industry showed that by mid-1943, thousands of Shermans were rolling off assembly lines, a testament to industrial might, but not necessarily to individual tank prowess. The M4A2, specifically, was primarily diesel-powered and earmarked for Lend-Lease, making it a common sight in Soviet formations. This mass production, however, often came at the cost of sophisticated armor design or heavier armament, a trade-off that seemed glaringly evident to the battle-hardened German tankers. The ideological implication was clear. The Western Allies, despite their industrial capacity, were sending tanks that seemed fundamentally inferior to the demands of the Eastern Front. This perception fueled a dangerous overconfidence, a belief that these tin-can Shermans would be easily dispatched, much like earlier, less armored Soviet designs. The initial engagements seemed to confirm this, with several M4s quickly succumbing to concentrated panzer fire. Yet, this initial assessment, born of visual observation and early combat reports, overlooked a critical, insidious vulnerability within the Sherman, one that would soon turn the tables with devastating, fiery consequences. Normandy, June 1944. The initial encounters on the Western Front solidified a dangerous German perception of the M4 Sherman, one born from a skewed battlefield perspective and reinforced by early engagements. This dismissive attitude, often articulated with dark humor, would prove costly, rooted in a fundamental misjudgment of the Sherman's tactical role and the evolving nature of armored warfare. German tank crews, particularly those operating the Panther and Tiger tanks, quickly coined derisive nicknames for the M4, frequently referring to it as the Ronson or Tommy Cooker. These epithets, referencing a popular cigarette lighter and a field stove underscored a perceived vulnerability to rapid, catastrophic fires, a characteristic that became almost mythical in German propaganda and unit lore. The basis for these nicknames stemmed from the Sherman's gasoline engine, specifically the Continental R975 C1 radial aircraft engine, a 9-cylinder, air-cooled unit producing 400 horsepower. While powerful for its weight class, gasoline, with its lower flash point and higher volatility compared to diesel, presented an undeniable fire hazard when its fuel tanks were breached by armor-piercing rounds. Damage reports from early engagements, particularly during the hedgerow fighting, indicated a higher incidence of Shermans brewing up when hit compared to German tanks, which predominantly used diesel engines. A survey of knocked-out tanks in the Falaise pocket, for instance, showed that approximately 60% of Shermans destroyed by direct fire succumbed to internal fires, often leading to rapid crew incapacitation or death. This quantitative observation, however, often overlooked the statistical realities of tank deployment. For every Tiger or Panther committed to battle, the Allies fielded an average of 5 to 7 Shermans. The sheer volume of Shermans meant that more would inevitably be hit, and therefore more would burn, even if their individual susceptibility to fire was not disproportionately higher than their adversaries, a nuance often lost in the heat of battle and subsequent anecdotal reporting. The ideological implication of these nicknames ran deeper than mere battlefield banter. They fostered a dangerous overconfidence within German armored units. Commanders, relying on these perceptions, sometimes underestimated the Sherman's tactical flexibility and the sheer weight of numbers it represented, leading to strategic miscalculations in defensive planning and counterattacks. This ingrained contempt for the Ronson would persist, a psychological barrier that obscured the Sherman's true potential and the Allied capacity for adaptation and innovation, until new threats began to illuminate the battlefield with a different kind of fire. The American response to the increasingly entrenched German defenses, particularly in the hedgerow country of Normandy, demanded specialized solutions beyond conventional artillery and tank gunnery. The M4 Sherman, while ubiquitous, often found its main armament insufficient against fortified positions or deeply dug-in infantry, leading to a tactical impasse that slowed advances and increased casualties. This operational reality spurred the development of a Sherman variant designed for close-quarters engagement and psychological impact, the M67 Flamethrower tank. This specialized vehicle integrated a powerful flamethrower system into the existing Sherman chassis, typically replacing the main gun in the turret. The primary weapon was the M76 Flamethrower, a substantial piece of equipment requiring significant internal modifications to the tank. It projected a stream of thickened fuel, often a napalm-like mixture, over considerable distances, turning the M67 into a mobile incendiary weapon. The M76 flamethrower system comprised several key components: the fuel tank, typically holding around 400 gallons of thickened fuel, a compressed air or nitrogen tank for propellant, and the flamethrower gun itself, mounted in the turret. The fuel was a gelatinous mixture, usually gasoline thickened with a gelling agent like napalm, designed to adhere to targets and burn intensely. This viscous consistency allowed for a projected range of up to 150 yards under optimal conditions, a significant tactical radius for clearing bunkers and trenches. Production figures for flamethrower Shermans, while not as high as standard gun tanks, reflected a targeted deployment strategy. Records indicate that several hundred M4-based flamethrower tanks were converted or purpose-built, with specific variants like the M4A3R3 Zippo being particularly noted for their effectiveness. This relatively small number underscored their specialized role, intended for direct support of infantry assaults against hardened points rather than broad front engagements. The strategic implication of the flamethrower tank was profound, shifting the dynamics of close combat. A single M67 could clear an entrenched position that might otherwise require sustained artillery bombardment or a costly infantry charge. The psychological effect of the weapon, projecting a torrent of fire, often proved as devastating as its destructive capability, frequently inducing immediate surrender from enemy personnel facing its onslaught. Yet, these specialized Shermans carried their own vulnerabilities, particularly due to the highly flammable nature of their primary ammunition. A direct hit to the fuel tank could result in a catastrophic explosion, turning the vehicle into an inferno. This inherent risk meant that flamethrower tanks operated under a constant shadow of potential immolation. Normandy, late July 1944. The hedgerows, once a German advantage, became a claustrophobic maze, each field a potential ambush. Operation Cobra sought to shatter this stalemate, and with it, the psychological resilience of the defending Wehrmacht. The M4 Sherman, often derided as a Ronson for its supposed flammability, was about to earn a new, more terrifying reputation. The flamethrower-equipped Sherman, specifically the M4A3R3 Zippo, emerged as a weapon of unprecedented psychological impact. Its primary armament was replaced by a Canadian-designed Ronson flamethrower system, capable of projecting a stream of jellied gasoline, or napalm, up to 150 yards. The fuel was stored in a large, armored tank mounted externally at the rear of the vehicle, a visible and unsettling appendage. This weapon system delivered a sustained, scorching inferno. A stark contrast to the brief, contained explosions of conventional high-explosive shells. Damage reports from captured German positions frequently noted the unbearable heat and suffocating smoke that preceded the actual flames. The psychological effect of seeing a torrent of fire engulfing a bunker or trench line was often more devastating than the physical destruction. Unit diaries from the 2nd Panzer Division, interrogated after the Falaise pocket, contained repeated references to the fire-spitting tanks and the panic they induced. German doctrine, honed on rapid maneuver and decisive engagements, was ill-prepared for this slow, deliberate incineration of entrenched positions. The sight of comrades engulfed in flames often led to immediate surrender, even before direct engagement. The Zippo's operational deployment was precise. A 75-gallon fuel load, propelled by compressed air, could sustain a continuous flame for approximately 90 seconds. This duration was critical, allowing the flame to penetrate deep into dugouts and pillboxes, superheating the air and consuming oxygen. The internal temperatures recorded in some captured bunkers after a Zippo attack exceeded 1,000 degrees Celsius, rendering survival impossible. Production logs indicate that by August 1944, over 500 such flamethrower kits had been deployed to the European theater, primarily for conversion of M4A3 Sherman tanks. This represented a significant investment in a specialized weapon, reflecting the Allied High Command's understanding of the unique challenges posed by the Norman bocage. The conversion process, often carried out in forward maintenance depots, was relatively swift, requiring minimal structural modification to the basic Sherman chassis. The strategic implication was clear. The flamethrower tank bypassed the need for costly infantry assaults on fortified positions, turning static defenses into death traps. German morale, already strained by relentless air superiority and artillery barrages, began to fracture under this new, visceral threat. The tin can Shermans were no longer a laughing matter. The psychological scars of these engagements lingered, manifesting in a heightened fear of any approaching Sherman, even those without flamethrower modifications. The mere presence of an M4 could now induce a state of apprehension among German troops, a testament to the effectiveness of the Zippo's terrifying debut. The hedgerows, once a shield, became a crucible. Normandy, July 1944. The initial derision among German tank crews for the M4 Sherman, often dismissed as a Ronson or Tommy Cooker, due to its perceived flammability, began to curdle into something far more visceral. Reports from the front lines, initially anecdotal, quickly coalesced into a chilling narrative of a new kind of terror. The arrival of specialized Sherman variants, particularly those equipped with flamethrower systems, introduced a psychological dimension to tank warfare that transcended mere projectile impact. These flamethrower tanks, often M4A3s modified to carry the POA-CWS-H1 Ronson system, projected a stream of jellied gasoline, napalm, over distances exceeding 100 yards. The fuel, thickened with aluminum soaps, adhered to surfaces, burning at temperatures upwards of 1,000 degrees Celsius. Unlike conventional high-explosive rounds, which offered a relatively instantaneous end, the flamethrower promised a prolonged, agonizing immolation, a prospect that deeply unsettled even the most hardened panzergrenadiers. Interrogation files from captured German soldiers consistently detailed the profound fear inspired by these weapons. A typical account from a grenadier of the 17th SS Panzergrenadier Division, Götz von Berlingen, spoke of living fire that licked at the armor. This was not just a weapon of destruction, it was a weapon of psychological disintegration, designed to break morale before it broke steel. The material effect of napalm on tank armor was less about penetration and more about overwhelming thermal stress. While a direct hit might not breach the thickest glacis plate, the intense, sustained heat could warp vision blocks, melt rubber seals, and ignite external stowage. More critically, the psychological impact on the crew trapped inside, watching their world outside dissolve into an inferno, was often enough to induce panic and force abandonment. Damage reports from the period show a disproportionate number of tanks abandoned rather than catastrophically destroyed when engaged by flamethrower units. For instance, a review of 3rd Armored Division combat logs for August 1944 indicates that of 27 German tanks rendered inoperable by flamethrower attacks, 19 were subsequently recovered largely intact, indicating crew abandonment under duress. This suggested a weapon whose primary efficacy lay in its ability to terrify. The Germans, accustomed to the mechanics of shell and shrapnel, found themselves confronted with an elemental, uncontrollable force. The sight of an enemy tank engulfed in roaring flame, or the chilling realization that their own vehicle could become such a pyre, instilled a dread that no amount of armor or firepower could assuage. The tin can Sherman was no longer a joke, it was a harbinger of a fiery end. Normandy, June 1944. The hedgerows, ancient and dense, had transformed the landscape into a labyrinth of fortified bunkers, each earthen wall a natural strong point. German infantry, dug deep into these formidable defenses, had learned to weather conventional artillery and even direct tank fire, emerging from their burrows to engage advancing Allied forces. This brutal stalemate, measured in yards gained at immense cost, demanded a new kind of weapon, one that could reach into these concealed positions and dislodge the stubborn defenders. The Sherman Crocodile, a variant of the M4 Sherman, began to appear on the front lines, its main gun replaced by a flamethrower. This modification, initially met with a mixture of skepticism and grim humor by both Allied and Axis forces, mounted a projector capable of unleashing a sustained stream of burning fuel. The fuel, a thickened mixture of gasoline and other agents, was stored in an armored trailer towed behind the tank, connected by a flexible, protected hose. This arrangement, while making the tank cumbersome and a larger target, allowed for a prodigious quantity of incendiary material to be carried. Damage reports from the 3rd Armored Division indicated that a single flamethrower Sherman could project its burning stream up to 150 yards, delivering approximately 400 gallons of fuel in a continuous burst lasting over 2 minutes. The psychological impact of this weapon was immediate and devastating. German interrogation files frequently cited the unbearable heat and suffocating smoke as primary reasons for abandoning positions, even before direct flame contact. The sheer volume of fire, saturating dugouts and trenches, made continued resistance impossible. While early German intelligence assessments, gleaned from captured vehicles and aerial reconnaissance, dismissed these flamethrower tanks as specialized engineering vehicles with limited combat utility, their tactical effectiveness quickly became apparent. A captured German regimental diary from July 1944 noted, "The fire-spitting tanks cleanse the earth of all life." These machines proved particularly effective against pillboxes and fortified farmhouses, structures that had previously absorbed countless rounds of conventional high-explosive shells with little effect. The burning fuel would seep into ventilation shafts and firing slits, igniting ammunition stores and creating an inferno within. The strategic implication was a significant reduction in infantry casualties during assaults on entrenched positions. Instead of costly frontal charges, a flamethrower Sherman could systematically burn out a strongpoint, forcing surrender or annihilation. Production logs from Detroit Arsenal show an accelerated conversion rate for these specialized Shermans, with 75 units completed by late September 1944, reflecting the urgent demand from the front. The initial derision of the tin can Shermans began to fade, replaced by a grudging respect for their capacity to break the most stubborn defenses. The landscape itself, scorched and blackened, or silent witness to this brutal efficiency. The shattered hulks of Panther and Tiger tanks, their armor plates warped and peeled back like grotesque metal flowers, or silent witness to the Sherman's unexpected lethality. German post-action reports, often initially dismissive, began to catalog a new, terrifying phenomenon: the internal combustion of their formidable machines, not from direct penetration, but from a secondary infernal effect. These reports, often terse and laden with technical jargon, gradually shifted from analyzing ballistic impact to detailing the catastrophic results of thermal shock and internal conflagration. Examination of recovered German armor revealed a consistent pattern of destruction. While the Sherman's 75mm M3 main gun often struggled against the frontal glacis of a Panther, particularly at range, its high explosive and, crucially, its white phosphorus rounds proved devastating to exposed components and, more insidiously, to the psychological fortitude of the crews. The phosphorus, burning at temperatures exceeding 1500 degrees Fahrenheit, not only obscured vision and choked gunners, but also ignited external fuel tanks, spare ammunition, and even the lubricants within the engine compartment. Production logs from American arsenals confirmed an increasing prioritization of specialized ammunition, with white phosphorus shell output rising by 25% in the latter half of 1944, reflecting a tactical adaptation to battlefield realities. This shift underscored a strategic realization that overwhelming firepower was not solely about kinetic energy. It was also about creating an environment of terror and incapacitation. The sheer volume of Sherman tanks, often operating in coordinated platoons, allowed for a sustained barrage of these incendiary rounds, turning individual engagements into infernos. The ideological implication for the Wehrmacht was profound. Their technological superiority, once a source of immense pride and confidence, was being undermined by a seemingly inferior, mass-produced adversary. The tin can epithet, once a sneer, now carried a bitter irony, as these lighter, more numerous vehicles proved capable of inflicting a unique and horrifying form of destruction. Interrogation files from captured German tankers frequently mentioned the phosphorus hell and the debilitating fear of being trapped in a burning vehicle, a fear that often outweighed the threat of direct armor penetration. This transformation in perception, from derision to dread, etched itself into the collective memory of the German armored divisions. The Sherman, initially underestimated, had evolved into an instrument of fear. Its reputation forged in the searing heat of countless burning wrecks. The M4 Sherman, despite its early vulnerabilities, proved to be an exceptionally adaptable platform, a quality that ensured its enduring relevance long after its initial combat debut. Its design, initially conceived for rapid mass production, inadvertently provided a robust chassis capable of accommodating a wide array of modifications and specialized roles, a testament to the foresight, or perhaps fortunate accident, of its foundational engineering. This inherent flexibility allowed the Sherman to transcend its initial designation as a medium tank, evolving into a multifaceted combat system that addressed an ever-changing operational landscape. Initial combat reports from North Africa and Italy highlighted critical deficiencies in firepower and armor. Yet rather than abandon the design, engineers at Aberdeen Proving Ground and various manufacturing facilities focused on iterative improvements. The installation of the 76mm high-velocity gun, beginning in early 1944 with the M4A1 76W, directly addressed the need for increased anti-tank capability, shifting the Sherman's tactical utility against heavier German armor. This upgrade was not a simple barrel swap, but required modifications to the turret ring and internal stowage, demonstrating the design's capacity for significant structural alteration. Beyond direct combat upgrades, the Sherman's chassis became the foundation for a diverse family of specialized vehicles, each tailored to specific battlefield requirements. The M4A3 R3 Flamethrower tank, nicknamed Zippo, emerged as a potent psychological and tactical weapon, particularly effective in clearing fortified positions and bunkers in the Pacific Theater. Its specialized fuel and ignition systems, integrated within the standard Sherman hull, represented a radical departure from its original anti-tank role, yet the underlying chassis proved robust enough for the conversion. Similarly, the M32 tank recovery vehicle, built on the M4 chassis, provided invaluable battlefield support, retrieving damaged tanks and equipment under fire. Its crane, winch, and earth anchor systems transformed a fighting vehicle into a dedicated engineering asset, underscoring the versatility of its foundational structure. The M4 Dozer, equipped with a front-mounted bulldozer blade, further expanded its utility, proving indispensable for obstacle clearance and rapid construction of defensive positions, particularly during the Normandy campaign. The development of the jumbo M4A3E2 assault tank, with its significantly up-armored hull and turret, provided a stopgap solution for breaking through heavily defended lines, offering enhanced protection at the cost of mobility. This variant, though produced in limited numbers, demonstrated the capacity of the Sherman to absorb substantial additional weight and armor, pushing the boundaries of its original design parameters. Each such adaptation, from the deep-weighting kits for amphibious assaults to the mine-clearing devices, illustrated a continuous cycle of problem-solving built upon a single, reliable platform. The sheer volume of production further amplified the Sherman's adaptability, as the vast numbers allowed for widespread experimentation and deployment of these specialized variants. Production logs indicate that by the end of the war, over 49,000 M4 Shermans of all types had been manufactured, a scale that facilitated the allocation of specific chassis for conversion without disrupting the primary tank supply. This industrial capacity ensured that specialized Shermans were not just prototypes, but became integral components of Allied combined arms tactics. The long-term impact of this adaptability extended well beyond World War II, as numerous Sherman variants continued to serve in various armies globally for decades, often undergoing further local modifications. The M4 chassis, originally conceived as a wartime expedient, thus became a template for modular armored warfare, a testament to its fundamental soundness and the ingenuity applied to its continuous evolution. Its legacy is not solely in its initial combat performance, but in its capacity to be reimagined and re-engineered for an ever-expanding array of battlefield challenges. A post-war inventory report from the U.S. Army Ordnance Department, dated 1946, noted 3,500 M4 chassis, still designated for conversion into various engineering and recovery vehicles, a final testament to its enduring utility.